Assalamualaikum and good evening, everyone. Can you hear me?
Yes, teacher, we can hear you.
Yes. Okay. How are you today?
Fine, very fine today.
I'm good.
Teacher.
What are you doing during PKPP? You still stay at home?
Yes, teacher, we must stay at home.
Why you don't go out? You can go, right?
Yes. Yes, we can go. We can go.
Okay. Okay. How about your online class? Is it great?
Not really too much assignments to do.
Oh yeah. Pitiful. How come? Okay. Can I continue?
Yes, teacher. You may.
Yes, teacher.
Okay. Show you a video about our topic, what we're going to learn today. Okay, let's watch it.
UV minus the integral VDU. Integration by parts. It will take some good old smarts. Take for example the integral ln x times dx. Let u equal ln x. Let dv equal dx. Derive a u and integrate dv. Now we have our variables. Integration by parts. 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 It will take some good old smarts. Integrated from the power rule. Use it so you're not a fool. Be on the lookout for a product of two functions that are unable for expansion. Proceed the process for using fees, but do not forget to accent. Integration by parts. Integration by parts. Integration by parts. Integration by parts.
From the video you watch, can anyone tell me what your rough idea from the video about what we're going to learn today? Anyone?
Integration by parts.
Okay, good, Asmina. Okay, today we were going to learn about integration by part. Can you see the slide?
Yes.
Yes, doctor. Yes, teacher.
Okay, good. Okay, today we learn about in chapter 7, principles of integral evolution. Our subtopic is 7.1, integral by parts. What is integral by part? Do you have any idea?
We are going to integrate the given function derivative apa? We are going to integrate by part. I mean integrate the given questions by parts.
Okay, good. Okay, integral by part is used when two functions are multiplied together. This is a general formula for integral by parts. We can see here there is u, there is dv. The left hand side is equal to our function given. Okay. From this question, the u is you can see right. This u you can easily differentiate, and dv is easily to integrate. Okay, from the function, we need to choose u and dv because it is two function, right? Can you hear me?
Yes.
Okay, there is two function, u and dv. This is a difference. So we need to choose which one is u and which one is dv. So we need to try Lopeti. Do you know Lopeti?
No, teacher.
No, teacher. Okay, Lopeti is refer to LO logarithm, P polynomial, E exponential, T is trigonometric, and I is inverse trigonometric. Okay, we see to choose you, we see from the top to down. For example, from the function given, you get a polynomial and a logarithm function. So we see. Okay, let's move.
Are you ready, class?
Ready.
Can you see my slide?
Yes, teacher.
Yes,
We
teacher.
can see the
Okay,
slide.
thank you for your response. Okay, next we learn about the integral by part. Integral by part have indefinite and definite. I will learn to you the concept of definite and indefinite integral. First, I explain to you indefinite integral. Second, I will explain to you definite integral. Now, we can see what is different between indefinite integral and definite integral. Okay, first, indefinite integral. Indefinite integral give a function f(x) and antiderivative. Antiderivative is integration of f(x) is any function f(x) such that f prime x equal to f(x). Okay, next. If f(x) is any derivative of f(x), then the most general antiderivative of f(x) is called an indefinite integral. Indefinite integral must be x plus c at the back. Why? Why we must plus c at the back, class?
Because it doesn't have limit.
Oh, that's right. Thank you. Okay. This is, for example, This is a indefinite integral. What is class?
Integral.
Integral sign. Fx. What is Fx?
Function.
This is integral. Okay, next, dx is called the variable of integration. C is what? Constant of integration. Okay. Yes. The indefinite integral of f with respect to x mean to find the set of all antiderivative of f. Okay. This is example rule of integration. For example, okay, we have the problem. This is, what do you think the answer for the problem? Who can answer this problem? Fazura, you can answer this problem?
Sorry, teacher, what's the question?
This is integral 3x power 5 dx.
The answer.
Yes.
3, wait Teacher?
Yes. You can answer this question?
1 over 2 x power of 6 plus c.
That's right. This is 1, 2.
Yes.
Yes. But I would like to show to you the process how we can this 1 over 2 3 hours. Okay, step 1, we need to add 1 to the exponent. This is exponent. 5 this is exponent. Okay, 5 plus 1 is 6. Okay, step 2, we need to divide it by the same exponent. Divide by 6. Step 3, we need to add the c. This is the answer. We need simplify. 1, 2. This is the answer. You understand, class?
Understood, teacher. Yes, teacher.
Okay.
You see the video?
Yes, teacher.
Yes, teacher.
Okay, this is the example 1 question. You can see here, there are 2 functions given. Right. Okay, we need to choose u and dv. Remember what I tell? You need to use law parity. Okay, we see from top to down. There are a polynomial function and exponential, right? You can see the question.
Yes, teacher.
Okay. Okay, we look at the locating. One we see first, polynomial. So polynomial will be the u. S. Okay. And automatically the other function will be dv. Square dx. This is what I say a previous one. U can be easily differentiate. We can get du dv dx, and dv we integrate, we get dv integrate, get v, and exponential integrate. Okay, we substitute the answer to the page for general formula. We just multiply as usual. And remember, this is indefinite integral by part. So you need to plus it at the end. Okay, until that, do you understand?
Yes.
Yes.
And
Okay, this is a table rule of integration. This is the formula rule of the integration. There are so many, but we learn this is number 1. We learn today. Okay, next. Avoid. Okay, I would like to ask you why we avoid this equation. Anyone?
Because it does. Teacher. Because it is not in a it cannot be simplified.
Okay, that's right. This equation, why we would to avoid?
It has two integral.
Yes, we need to want the integral only. Okay, this
Same. It has two integral. No, it cannot be simplified.
Okay, this cannot be simplified. Okay, do you understand what is indefinite integral? Before I would like to learn you about the definite integral. Do you understand indefinite integral?
Yes.
Okay, next.
yeah,
We learn about definite integral. Definite integral have a what? A and B ni what? Call A and B?
Lower and upper limit.
Lower and upper limit. Good. Okay. This is properties of definite integral. First, the definite integral of 1 is equal to the length of integral of the interval of the integral. This is a formula. Okay, second, a constant factor can be moved across the integral sign. This is the formula. You need to remember this formula. Okay, third, definite integral is in the independence of variable at the integration. Okay, fourth, if the upper limit and the lower limit of definite integral are same, then the integral is 0. Why is it 0? Okay, next. Removing the limit of integration change the sign of definite integral. Next, the definite integral of the sum and difference is equal to the sum and difference of the integral. Okay, next. This is a area under curve A, B, C and D. This is the formula. This is area between under curve area of A, B, C and D. What is different between area under a curve, area between under a curve? What is different between these two class?
I don't know, teacher.
I don't know, teacher.
This. At the area under a curve, the line is under the x-axis. Area under a curve, they touch A and B touch area x-axis. But area between under a curve not touch the axial axis. This is a difference between area under a curve and area between under a curve. Okay, let's go. We have a problem. What is the answer? Volunteer. Who want to answer the question? What is the answer the question, class?
Wait, teacher. Calculate. We are calculating the solution.
You get the answer?
Can I try?
Okay. Can. What your name?
Is it 4? Is it 4?
4. Okay, we see together. This is the answer. 14/3. Why we get the 14/3? Okay, I will show to you the process. Okay. Step 1. We need to add 1 to the exponent and divided by the same exponent. This. Okay. 1 is x. Okay. Next. Step 2. Simplify the exponent. We get 3 power x power of 3 over 3. We simplify the exponent. Step 3. We need to substitute the limit integration into x. This. We substitute to the x. We need to subtract under two limits. Under between two limits. The answer is 14/3. Okay. For conclusion, indefinite and indefinite integral, there are no upper and lower limits on integral. And what we get is an answer still has x in it and will also have a constant, usually denoted by c. It is. But definite integral has a upper and lower limit on integral, and it defines because at the end of the problem it have a number. That's right, class. Definite not have a x, but it have a number. That's right, class.
Yes.
Okay. It is a definite answer. Fazura,
Yes, teacher. Yes, teacher.
I would like to ask you what you understand about indefinite integral.
Indefinite integral, it does not have upper and lower limit, and it have constant c at the end of the answer.
Okay. Yasmin, what you understand about the definite integral?
Definite.
Definite integral.
Definite integral does not have constant and does not have x in the integral sign.
Okay,
It has lower and upper limit.
Okay, that's right. Thank you.
Hear my voice?
Yes, teacher.
Okay. Yes, teacher. Okay. Okay. Now I will show to you guys some of example indefinite of product using integration by parts. Okay. As you guys can see, example 1, we need to find the integrate of x squared. Teacher, there's no slide. Oh, no slide? Wait. Kan slide kau kenapa ni? Ni tak nampak ni slide. Korang nampak apa Google Meet. Google Meet je. Sekejap.
Nampak awak je.
Nampak saya je. Sekejap. Alamak. Example. You are
Saya tak boleh
present. Sekejap. Stop present. Entire screen kan? Okay, can you see? Yes, teacher. Yes. Okay. Now I will show to you the example of indefinite of product using integration by. Okay, as you guys can see, the example 1, we need to find the integrate of x squared, exponent of 3x. Okay, and the solution is like this in the diagram. Okay, first we have to list out the u and the dv, which is the u is square. The u is x square. The dv, why we use x squared as a u?
Because we follow the Lopeti rules.
Other than that answer, anyone? Why we need to use? We have to take the x square as the u and dv as the e exponent 3x. This is because we have to choose the u for the equation that easy to differentiate. As we can see, x square is easy to differentiate, and if we differentiate x square, we will get 2x. Okay, and when we remove the x, which is e exponent 3x, okay, the v, when we integrate, we will get e 3x over 3. Okay, then substitute in the formula. The formula based on the previous
as the other teachers show. Okay. Until this, you guys understand or not? Until here. This is for indefinite. You guys understand why we get this?
Understand, teacher.
Okay, this is you. Okay. This is you. Okay. This is V. Which is the V is this one. This is V, and this is the U. Okay, and minus integrate of V du. This one V and du is one. Okay. Okay, the resulting of integral, then we still get product. Still product. As you guys can see here, x, the integrate of 2 over 3x exponent 3x is still product. So we have to differentiate, we have to use the formula integral by part again. Okay, the resulting of integral is still a product. We can use the formula again to evaluate this one. Okay, and then just use the formula again, list out the u, the du dx, and differentiate this one, dv, and integrate the dv, and then okay, so you will get this one. The second, when you use the second formula again, you will get this one. This one you will get from this. Okay. Then substitute, and you will get this. Understand? Understand or not?
Yes, understand, teacher.
Then okay. It's okay if you don't see the flow. We will do the exercise later. Okay, next example 2. X ln x. Okay, the u, choose the easy to differentiate, which is ln x, 1 over x. The du is x. And then you will get this. Just substitute by using the integral by parts formula. Okay, next for example 3. Example 3, we choose 5x as a u because it is easy, like I said, easy to differentiate, and dv easy to integrate. Then you get this, and then substitute in the formula, differentiate this one, and differentiate, you get this. This one, the constant value, you should put it outside, and then integrate the side, the left of equation, and then get this one, and then just multiply and get this. Okay. Don't forget to put the c plus c. Okay, now let's do exercise. For example, I want you guys to show the work, your calculation for exercise number 2. Can I give you guys for 5 minutes to do this? 3 minutes, no? 3 minutes. 5 minutes is too long.
Okay, teacher.
3 minutes. If any questions, you can ask me.
3 minutes for one question, ke teacher?
One question. Exercise number 2 only. Do the number 2 first.
Okay, teacher.
Okay. Okay, 1 minute left. Okay, time's up. Can someone show me your calculation? I want to see your calculation. Any volunteer?
Wait a minute, teacher.
Okay, I'll give you another 2 minutes.
Teacher.
Yeah.
Nampak ke? Do you see? No, nothing. I do.
Okay. Okay, your final answer? I want to see your final answer. Negative. Okay, correct. Thank you.
Welcome.
Okay. This is the solution. Okay, understand? Everyone understand? Get the answer?
Yes, teacher.
Yes, teacher.
Okay.
Yes, teacher.
Okay. Okay, next try to do exercise 1. And I will call someone to answer and to show the calculation. Okay, 3 minutes starts from now. Okay, for exercise number 1, I will call Ming Ming to show your calculation.
Okay, sekejap ya.
Okay.
Teacher, can I look at the answer or not? I want to confirm my answer.
Answer. This one. This one. You got the same or not?
Buka kamera ke? Do I need to open the camera to show my steps?
Okay. Let's open your camera. Okay, good. Thank you.
You're welcome.
Okay, next we move to the integration by parts of definite integral. Okay, this here is the example 1. Solve 2x squared ln x dx. Okay. The upper and lower limit value is from the top is e exponent and 1 at the bottom. Okay. To solve this example, you just follow as like the indefinite formula. Just follow, just find the u, find the dv, u ln x dv 2x square. And then integrate using the formula, using integral formula. Integral by part formula. Okay, and then we'll get this one. Okay. And then at here, when you have find the final, you must to substitute the value, the limit value, which is 1 minus exponent or exponent minus 1. Which one?
Exponent minus 1, is it?
Yes, correct. Okay, substitute the value that you have integrate using the formula. First, substitute substitute the exponent value, then the exponent value minus the value that you have insert for the one value, and then you will get the final answer. Okay. Next, example 2. solve x power 7 non-x dx. And the upper and lower limit value is exponent 3 and 1. Integrate like usual using integrate by parts formula. Then we will get this. When you have done integrate like definite, like the definite question, indefinite, and then just substitute the value. Substitute. And then get this one, the final answer. The exponent value, you no need to insert in the calculator. Don't type exponent 24 because it will get large number. So just list the exponent 24. Don't solve the exponent. If you solve the exponent, you will not get the answer. Okay. Then you get this one. For this one, this part, you have to factor out the exponent. Then you will get this. Understand until here?
Understood.
Okay. Then we move to the exercise. This definite integral just same as indefinite, but you only have to substitute the value of x using the value that given at the lower and upper limit. Okay, try to do exercise number 2 first, and then you show me exercise number 1. I want to see your calculation for exercise number 2.
Alright, teacher.
I will choose person randomly. I give you 5 minutes because you have to insert the value, right? If you have any question, you can ask me. Okay. I will choose randomly. Okay. I want Anis Suryana to show me your work for an exercise number 2. Anis, have you done?
Yes.
Teacher, you need to pin her.
I cannot see. Okay. That's my mistake. Okay, correct. Thank you. Okay. Right. For exercise number 1, I will call Ivy. Ivy Christie.
Wait, teacher.
Okay.
Can you see it?
I cannot see. Move to the left. Okay. I cannot see your final answer. X 8 long 2. Okay. Okay, correct. Thank you. Okay. Okay, that's all for the example and exercise of the product. Okay. Do you have any questions based on what we have learned just now? Any answer or any question?
No, teacher.
Okay.
Okay, hello and good evening, everyone. Hello, good evening.
Evening,
Good
teacher.
evening, teacher.
Can you hear my voice? Is it clear?
Yes.
Okay, before I start, I want you all to open your camera. because I want to see your beautiful faces in this beautiful evening. Okay? All of you. Alright. Shaf, stop presenting. Okay. Nur Anis, where is Nur Anis? Are you still awake? Yasmin? Okay, do you have the spirit to learn?
Yes, teacher. Memang.
Gonna fall asleep, yeah? Okay, so I will be conducting the last session of our lesson today, which is the assessment part. So, firstly, I want to ask you, how do you feel? Is it okay? Do you understand your teacher just now presenting? Can you understand?
Yes, teacher.
Yes, teacher.
Alright, good. So seems like you are ready for quiz, right? Are you ready for quiz?
Ready, teacher.
Yes, teacher. I'm ready.
Alright, so okay, wait up. I want you to search for quizzes on your Google to join my quiz, the quiz that I have prepared. So I will share the quiz code on the screen right after this. And I want you to attempt quiz in 6 to 8 minutes. I think 6 minutes is enough because the questions quite as long as you got what the teachers are presenting just now. So can you see my screen?
Yes, teacher.
Can you see?
Yeah.
Okay. Go to Google and open the quizzes. Okay. So I will share the code. So have you guys all opened already the quizzes?
Yes, teacher.
Yeah. Already open? Hello?
Yes, already open, teacher.
Pardon me because my line isn't very stable right now. Sorry, taking some time. Okay, this is the game code and you can start. Okay, have you done?
Yes.
How to end this? Okay. Alright. Okay, I think everyone has finished answering. Is there any problems that you faced during the quiz? Is there anything that you want to discuss together?
Yes, teacher. Could you
No?
discuss about the last question of the quiz?
Uh,
The question is about x cubed ln 4x 3x.
the last question.
Yes.
Oh, that question. Okay. If we do it together, I have prepared a recorded video on how to solve that question, so you can watch this, okay? Can you see? Okay. Okay, class. Ivy, do you get it now?
Yes, teacher. Thank you, teacher.
And which part did you get it wrong? Can you tell?
I get it wrong by dividing the part of that integral.
Oh, okay. So next time, beware of making silly mistakes. Okay, students. We often do the same mistakes over and over again, and that silly mistakes cause a lot of marks. So your marks will be reduced. So it's such a devastating mistakes that everyone should avoid. If you keep on doing that, you would not be able to score well. So before you write down your answer, you must recheck back your answers to avoid these simple mistakes. Okay?
All right, teacher.
Okay, so students, anything else? Do you have any problem?
Not.
No.
Teacher.
No, teacher. Okay. Okay. Can you please turn on your camera again? I want to see every one of you if you are still awake. Because we are going to conduct last session, and after that we shall dismiss the class. So I want to see your faces. Okay, so let's move on to the last part of our class, which is the brainstorming session. So in this session, I'd like you to recall back what have you learned today. And for this, I want some volunteers to share what you learned. For example, what, when, and how to use integration by parts.
Can I try?
I want some volunteers to share their thoughts. Any one of you?
Can I try, teacher?
Anyone can share?
Yes, teacher. Can I try?
Yes, sure.
Okay. Based on what I've learned today.
Yes, sure. Go ahead.
What is
Okay.
integral is it is the inverse of differentiation.
Yes.
And
Sure.
for the integration by parts, it is a technique in integration that involve combination of two functions. About when,
Okay.
it a product when two functions multiply together.
Alright.
And how is we choose u and v. U is for differentiate and v is for integrate, and by choosing those both we can make the second integral easier using the formula integral u dv equal to uv minus integral v du. Okay, that's all.
Alright.
Thank
Very
you.
good sharing, Ivy. Thank you so much. So, the next, one more volunteer. I need one more volunteer to share your thoughts about today's lesson. If no one, then I can pick anyone. Okay, so I pick randomly. I want to ask Tiong Ming, can you share some of your thoughts about today's lesson? Ming? Can you share? Hello, Ming. Okay, it's okay. So I would want to call Yasmin Sofia. Yasmin, can you share a bit of today's lesson?
So for today's lesson, hello. So for today's lesson, I learned about indefinite integral and definite
Yes.
integral. Where indefinite integral,
Okay.
we have constant plus constant, and definite integral we don't have any constant, but we have upper and lower limit.
All right.
You want more?
Anything else? Yeah.
Today
Anything that you want to share?
I learned about how to do integration by parts too. Integration by parts apply when there is two functions. So we need to choose what is u and what is the dv
Yes.
for us to solve the equations. So that's all.
Okay. All right. Thank you so much for the sharing. I think you have already clear about this topic, integration by parts. You can see how integration by parts works, and you can differentiate the function. You can integrate the function, and you can solve the questions regarding this topic. So I hope that all of you receive what the teachers wanted to deliver to you today. And if you face any problems, any questions regarding this topic in the future, you can simply ask us and we will help you as long as we can. So I think that is all. Thank you again for being cooperative and thank you for spending your time in this lesson today. And we hope that every one of you success in the future. So that is all for today. So I dismiss the class. Thank you so much. See you all again.
Thank you.
Thank you, teacher.
Stay safe.
Thank you, teacher.
Thank you, teacher.
Tadi ada
Thank you too. Welcome. Yeah. Thank you guys.